Test one, two, cool. We'll be attempting to solve Advent of Code 2025. We've been a little late this year, but let's try to solve some problems today. I haven't attempted or read any of them before, so let's see how the live problem solving goes. Okay, day one, secret entrance. They always have good news and bad news. The good news is that they have discovered project management. This has been their tools. Not full decoration need to be finished soon so that the critical get back in 2 minutes. Hello, mic test. Live. See. Okay, cool. Let's get started with the first problem. The bad news is that I've realized they have different emergency. According to the resource planning, none of them have any time left to finish decorating before December. Collect stars puzzle. Two puzzles will be made available next day. The second puzzle is unlocked when you complete the first stage puzzle. And one star. Secret entrance at the North Pole is ready to start decorating. Unfortunately, the password seems to have been changed. Can't get in a document. If will explain. Out in the shape tile. Only an arrow on it. Around the tile are the numbers 0 to 99 in order. As you turn the dial, makes a small click noise as it reaches each number. Puzzle input contains a sequence of rotations, one per line. Open the safe. A rotation start with an L or that's the distance value is how many clicks should be rotated. Okay. Basically modulus to the left or right for a particular point. We have to take the absolute value. If the help are pointing at rotation or it would cause a okay, understood. Okay. Circle 0 becomes 99, so we are taking modulus 100. If the dial were pointing at 5, examples are fine. Given this number, we start at what? The actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. That starts at 50. This it becomes the number of times it becomes 0 is the answer. So in this case, 3. We get the sample input first. Okay, so I need to use Vim only, not well versed with Elix yet. I can use Python as well, but it's fine. Line, need to take the lines. We only need to take in non-space character lines, so they should be fine instead of using a get line scene. So direction 0 and rest will be your number. Let's say count should be a substring starting from index 1, and let me find the actual value for it. So string to integer of count. Let's print these values that we know we are passing the input correctly. I hope my LSP is working fine. We need to provide the input. Okay, fine. So parsing is working fine. So let me start with the initial, let's say rotation. We're at 50. Say we are using R as the variable and answer is 0. And if direction is left, we need to perform a minus value plus 100. Let me also use a this constant for this. Should be R minus value plus mod, modulo mod. Plus, and answer should be incremented by 1 if R is 0. Let's see the answer for this case. I have the violation flags. I think so. Okay, so we are getting 3 for this. So let me download the actual input and get the answer for that. I hope the numbers are okay. So this will be a little bit problematic because we have numbers above 100. The modulus could get hampered, but there is a simple solution for that. So let me try to get the input first. This is the input, and what I need to do here is, let's say we have a large number, infinity for now is again 1000, and I add a multiple of this so that the values don't get overflown. If this could be negative, but adding a multiple of mod doesn't affect the actual result. That's why I'm adding a large multiple of mod here. This case is not required, so do this and check on the sample input again. Let's try actual input 1036. Looks correct. Let's move on to the next part. Before that, let me also initialize a Git repository for this. So I need to stage sample input sample and the function. Let me also do one thing, move. Should I use two different programs for part 1 and part 2? Okay, let's do that. Okay, so let me stage this, unstage this, and use main as the second part. Okay, so let's go to the part 2. You're sure that's the right password, but the door won't open. You know, but no good answer is you built a snowman. You think another security document that must have fallen into the snow due to new security protocols. Please use password method. This until further notice. You remember from the training seminar that method. So max value means you're actually supposed to count the number of times any click causes the dial to point at 0, regardless of whether it happened during a rotation or at the end of one. So we need to find out while incrementing or decrementing the value whether it goes over 0. So we start at 50, dial is rotated, This time it didn't go over 0 because it went from 50 to 82 and there is no 0 in between them. So no, right, so this was L, my bad. So 50, 82, it made a single rotation through what we call the pivot point 0. So let me use a naive approach here instead of doing some formulations. What I wanted to do here is, let's forget these infinity calculations. I will but what about multiple zeros in a single rotation? Do we count them as single time or multiple time? So we just need to check whether it happens during any click. I think we need to find it only once. Let's say this is a very naive and bad approach. So let's use I don't think the input is even large enough to handle that. So I'm fine with this. So R becomes R minus 1 since we are moving one left. And if this becomes 0, it became 0 is false and became 0 is true when R is okay. I just need to update it once. So let me take a bitwise OR for this. Either it is already true or it becomes true for this particular rotation. And I also need to should be equals, and I need to perform the modulo. So if R is 0 or R is minus 1, then it becomes 99. So minus 1 becomes 99. And answer is incremented if the value became 0. The same calculation here. This time we are incrementing the value becomes 0. But before we check this, we need to check whether this is 99 and then update it to 0. This is not required. Let's see for the sample. The answer should be 6. Perfect. So let's me try the actual input. What is the input? Okay, this is probably due to some parsing error. Let's check that. String to int. But this is not the input, my bad. It should be in 1. Right. 2503. That's not the right answer. Okay. Either it's this or I need to count it however many number of time it goes to 0. 0 single rotation. Okay, right. So my bad. I forgot to read this particular point. So if we are rotating it a large number of times, it would cross 0 a multiple number of times instead of just once. That was my initial assumption. So let me correct that. I just need to do this and to use an integer value here, and this should be incremented if r is 0. Same here. Let's try a sample. Six 159. Okay, again, wrong answer. Let me see what else could be wrong here. This should be 100. My bad. What else? For left rotation we are decrementing, for right we are incrementing. This should be correct. This is an integer value for both the cases. Let's try this again. Okay, so the issue was that I was using 99 as the first value when you increment and you exceed the mod value. So we have a mod value of 100. So the values lie in the range 0 to 99. But if I use a 99 here, I was basically considering the mod value as 99 instead of 100. So yeah, that was the bug. So yep, day 1 is complete. Let me commit this first. I need these sample input, sample output, main 1, main 2. I'm not worrying mostly about any code clean code or any optimized code for now. I'm just trying to solve the problems. Okay, let's commit this. End of code 2025 day 1 solved in C++. Okay, let's move on to day 2. You get inside and take the elevator to its only other stop, the gift shop. Thank you for visiting the North Pole. Playfully explains, okay, this is not relevant. Make sure surprisingly extensive selection. One of the clerks recognizes you and asks for your help. As it turns out, one of the younger elves was playing on a gift shop computer and managed to add a whole bunch of invalid product IDs to their gift shop database. Surely it would be no trouble for you to identify the invalid product IDs for them, right? Okay. They have given checked. They have even checked most of the product ID ranges already. They only have a few product ID ranges for your puzzle input that you need to check. For example, comma separated range values. The ID ranges are wrapped here for legibility in your input. They appear on a single line, long line. Okay, I just need to input a single line. The ranges are separated by commas. Each range gives the first ID, last ID separated by a dash. Since the young elf was just doing silly patterns, you can find okay, I got a chat from Ritvik. Okay. Since the young elf was just doing silly patterns, you can find the invalid IDs by looking for any ID which is made only for some sequence of digits repeated twice. So 55 is 5 twice, 64 is 64 twice. I just need to find the, so this algorithm is basically finding the longest prefix which is appended multiple times to itself. None of the numbers have leading zeros. Okay, Your job is to find all the invalid IDs that appear in the given ranges. But what is an invalid ID? There's two invalid IDs. Why? I'm getting a sense that the puzzle input for the part 2 would be much bigger number. So I will try to solve this using an optimized approach even for part 1. Let me go through the question once again. Ranges are separated by comma and separated by dash. Since the young self was string selling patterns, you can find the invalid IDs by looking for any ID which is made only of some sequence of digits repeated twice. Okay, my bad, this is repeated twice and not a arbitrary number of times. So the length of the number should be even. If it is repeated twice, the length should be even. That can prune my search by half for a particular range. And what else? Basically, if a number is repeated twice, what I can do is I can iterate over the first half and check, create the second half and check whether it lies in the LNR range that is given in the input. That could be one of the approaches. And let me check once again. You can find invalid IDs by looking for any IDs which is made sequence of digits repeated twice. Okay, so I just need to find the number of numbers in this range which have this particular format. Invalid ID. The definition is kind of opposite, and so they are saying that this is an invalid case. So I was assuming this is a valid case, and we need to find the opposite one. But that's fine. Okay, let's start with this part. I don't think they have given any maximum range for the input. Let's try to check this. Okay, looks like we have 10 raised to 3, 6, 9. So I'm assuming the numbers could range anywhere between, can have length up to 10. So I can iterate over the first half and okay, so I have an algorithm in mind. So let me start and go over the implementation. Which programming language should I use? Let's do this in Python. Say in 1.py. Okay, so the input is one single line. I need to get the line input. I think I need to split it first on comma. Let's do one thing. Let's read the input from file only. So how do we read Python file into string? Okay, let's do it in simple manner only instead of bloating the code. So this will take in the standard input. This will have, these are ranges, and let's try to print the ranges first. So Python 3 main 1.py. Let me also get the sample input first. Python 3. Okay, perfect. So these ranges looks like they are decoded. I don't think so. We only have a small number of ranges. What's the issue here? Maybe while pasting it has created different lines, correct? So let me remove the new lines and try it again. Okay, now we have all the ranges. Now I need to, let me bring the terminal here itself and minimize this a little bit. Okay, perfect. So I was doing this. Okay, for I can't use the range keyword, but the LR. What do I name this? Let's say value in ranges. I need to extract out the left and right and right value of the range. So this should be value dot split on hyphen. Let's print this. Okay, fine. We got these numbers. These are probably strings, so I also need to convert them. Let's perform a map. Let's try again. Okay, parsing works. Now what I wanted to do is let's also create answer variable which stores the final answer. This should be part 1 answer. I hope I'm getting the f string syntax correct. So this should be answer. And I need to go over this range, but I'm not doing it in a brute force manner. I will use some kind of pruning just so that whenever I'm exceeding a particular value, after which I will never find invalid case according to this question, I will break the loop. So in general, this particular loop should only have at max 10 raised to 5 iterations at most. Let's say this is x, or x in range L to R plus 1, because Python loops are non-inclusive for the right endpoint. So this is a string. No, my bad. This is an integer. X is an integer. And what I need to do is, so x, let me also write this down. So in this particular case, x is 1, 2, 3. And I need to check whether x or the value appended to itself, this value is in range L to R, or simply less than R, less than equals to R. Okay. For this, I need to check let value string representation of x, and I can do a multiplication operator on this just to append the value to itself. And let's again convert this into an integer, because we need to check whether it lies in the range. So if valid, let's say value is less than equals to R, then answer is equals to 1, and else we can break the loop, because if if a value exceeds R, then any value after it also exceeds R. So that way, and why I said that it only has 10 raised to 5 iterations is because, let's say R is a large number which has 10 digits. So X can have, this means X can have at most 5 digits. 5 digits, approximately 10 raised to 5 iterations. That's, there must be some error here. So value range is split. Printing is correct. Let me check if it is calculating the value correctly. And let's do this only some number of times, or let's say break for now. Looks like it is calculating it correctly. Okay, I think I know the issue. Instead of starting at L, I've started at L, and X should start from 1. Let's do this, but this breaks my assumption. No, I think this should be fine. And in fact, I think this should simply be an infinite loop starting from 1. So this one is true. And I need to increment X here. I think I'm counting the number of invalid numbers. Instead, I should take this sum, adding up all the invalid IDs. Has fun. Okay, let me add. Okay, still it's not correct. Let's try for a simpler input first. We have 11 and 22. This looks correct because we have summed up 11 and 22 as 33. Let's try 95, 15. Okay, so this is incorrect. Let me also print what all values I'm considering. Okay, my bad. So this, when I change the loop from L to R, I started 1, so I just need to check whether this lies between L and R. And I need to break if value is greater than R. That should be the case where I should exit the loop. Okay, looks good. Answer is correct. Let me get the actual input. I hope the pasting is correct. All values on one line. Okay. Okay, it took some time, but not too much. Hopefully this should be enough. I don't have to invent something else for part 2. Okay, so part 1 is done. Let me commit this. I need what? Let me clean up the day 1 solution. I don't need this. The binary. And this I need main 1, sample input and actual input. Okay. Day 2 part 1 solved in Python. Okay, let's move on to part 2. We'll be back in a minute. Only has 10 raised to 5 iterations. Okay, I'm back. Let's go to part 2, day 2. We'll quickly discuss that there are still invalid IDs in the ranges in your list. Maybe the young elf was doing other silly patterns as well. Have an ID is invalid if it is made only of some sequence of digits repeated at least twice. Okay. This is not that difficult. In fact, the time complexity or the number of loops that you are going to go through reduces in this case. Okay, so this, all of these are valid, and but the case where you are doing at least twice, right? So I don't think we are counting single digits, so that should be fine. The example before, so I have one idea for this. We main 1.py 2.py. So I need to update this code only. Remove these comments for now. what we need to do here is introduce a new while loop which goes over this particular value of number of appends of the number to itself. So this 2 is the variable now. So let's see. Let's do I think the input stays same, right, for part 1 and part 2. Okay, it hasn't changed, so we're using the same input, and we have the same upper bound of 10 is to 10, which is 10 digits. This should be fine. Let me use, so if we have a single digit number, 1 2 3 or anything like that, it could be appended 10 times and it could still be less, or could still lie in this range LNR. So I think for the upper bound of the number of repetitions for this variable, let's start with 15 because Python can handle big integers for us, so that is not an issue. So let's say appends in range start with 2, and let's say we go all the way up to 15 just to be safe, and this entire thing uh, lies inside the loop. This value we need to append it this many number of times and check whether it lies in the range. If it is, we are still calculating the sum, right, adding up all the invalid IDs, and we need to find out all the numbers which lies in the range. So if I just glance over the first part solution, we were calculating the answer if it lies in the range once, which was for twice repetition, and in this case for however number of iterations. So this is fine, but when do we exit this external loop? I think when do we exit this loop? I mean, I can introduce a hard bound on this, let's say 10 raised to 6 or something, but it would introduce a static constant, which I would not prefer to do it that way. The first value of x when it exceeds r should be the case. So let's say we calculate this again and do this for twice repetition, and if this exceeds r, then I break the external loop. Let's try this. Okay, no, answer is slightly off. 4174. Okay, this is not correct. Hmm. Think on this. So what am I missing here? Let's go through the sample input route. Let me print. total values we are adding. So taken sample, we have taken 111. That's correct, and we also taken 99, which is correct. How about 1122? This is also correct. 998. 12. This is also correct. Let me try this bigger range. 11885. 11. Okay, this is fine. Sum is also correct. Hmm. I don't think overcounting should be an issue here, because every number will create a unique uh, invalid value once it is appended some number of times to itself. This is fine. Let's see for what case we are wrong. 1122 is fine. Also fine. 99910. This is correct. This one it has taken multiple times, so this particular value should only be taken once. Same character, same number repeated. So this is like 2 repeated 6 times, or 22 repeated 3 times, or 222 repeated 2 times. So my code is taking all of them as different. Instead, what I can do is I need to store the values in that case if I need to find out the unique values in the answer. So let's go over the brute force approach again. I'll just store it and then take the sum from the set. So let's say vals is a set, and instead of summing it here, I will add the value in the set so that duplicates are only counted once, and my final answer should be sum of values in this. This looks correct. 79262. Let's go over the actual input. Let's try this. That's not the right answer. Wow. Why did I get the star? Okay, that's the right answer. Okay. Okay. My bad. I didn't know why I read that. But yeah, fine. I think day 2 is complete then. Okay, so not that difficult, I would say. A little bit tricky just to form this, and luckily they had provided this particular case which was failing for me, so it was easier to identify that and change the code accordingly. Okay, looks good. Let's commit this. I don't need the sample. This solved day 2 part 2 in Python. Let's move on to day 3. Okay. You descend a short staircase, enter the surprisingly vast lobby, and are quickly cleared by the security checkpoint. When you get to the main elevators, however, you discover that each one has a red light above it. They are all offline. Sorry about that. An elf apologizes as she tinkers with a nearby control panel. Some kind of electrical surge seems to have fried them. I'll try to get them online soon. To explain your need to get further underground, well, you could at least take the escalator down to the printing department. Not that you would get much further than that without the elevators working. That is, you could if the escalator weren't also offline. Okay, all this seems irrelevant, but don't worry, this is not right. Just need power. Maybe you can get it running while I keep working on the elevators. There are batteries nearby that can supply emergency power to the escalator just for just such an occasion. The batteries are each labeled with their voltage rating value from 1 to 9. You make a note of the voltage ratings, your puzzle input. Okay. The batteries are arranged into banks. Each line of digits in your input corresponds to a single bank of batteries. Within each bank, you need to turn on exactly 2 batteries. The voltage that the bank produces is equal to the number formed by the digits on the batteries that you turned on. For example, if you have a bank line 1, 2, 3, 4, 5, and you turn on batteries 2 and 4, okay, you cannot rearrange. It is like a subsequence of length 2. You'll need to find the largest possible voltage bank can produce in the above line. Okay, you can make the largest one 98. Just need to find out the 2 numbers. The brute force approach is like 2 nested for loops, but let me check if the input is small enough to handle that. I think it is fairly small, so I can move ahead with the brute force approach for part 1. Maybe there is some optimal approach expected in part 2. I will do this again in Python only. Okay, so how do I get multiple lines in Python? I think I need to this. I forgot the syntax. So for line in input, let's print line. What is the sample input? These 4 lines. Okay. Okay. Python 3 main 1 input is in input 1 file. Okay, looks like it didn't get it right. I think. Why did it take the input in such a manner? Character. Why? Okay, this looks correct, but I'm not sure why it. Python read standard input line by line. Don't think there is anything else here. For line is standard input. I think this should be fine. I don't know why this is not working. Do I have to check my earlier code for this? Testing. Let me check the file. I think it's correct. Okay, this is file input. Let me check some other program. Again, this is file input. Let's do this only then. I'll get the put line by line to the other. And my input is in N1, so let's use in1 here. I will read this, and then I think this should give me the lines as a list of strings. If I go with this, so why is it given same result again? Select. I think I also need to trim this. It's the type of this. It is a list of strings. So what I'm trying to get rid of is this particular empty line. Let me do this. This. Okay, not valid. Let's do this in a simple manner instead of wasting time. Okay. We got the line, and now I need to, let's say length is n, I in range n, or j in range n. If I is less than j, I need to form a number, and do I need to add it, or yeah, I need to add it. So let's say answer is 0. Need to find the best number. Best should be max of best, comma, the integer value of the number formed when we take line of I and line of j, and at last we need to add this particular value. And part 1 answer is 357. Looks correct. Let me get the actual input. Okay, looks good. Let me change the input file for the program. answer is 17535. Looks good. Let me commit this. I need these and this. Day 3, part 1, solution in Python. Let's copy main1 to main2. Let's see what they're asking for part 2. The escalator doesn't move. The elf explains that it probably needs more jolters to overcome the static friction of the system and hits the big red jolters limit safety override button. You lose count of the number of times she needs to confirm yes, I'm sure, and decorate the lobby a bit while you wait. Now you need to make the largest joltage by turning on exactly 12 batteries within each bank. But what is the length of this particular thing? 15. Okay, not that bad. And let me try for one of the inputs, the real input case 100. So we have a 100 length array of digits, and we need to find a subsequence of length 12 which has the maximum numeric value amongst all of the possible cases. 12 digits in each bank voltage of 2. Okay, I'll probably use dynamic programming for this. The total output is fine. Okay, the question is clear. So let me think if there is a easier approach to this or not. There, I think it can be solved greedily, but I'm not quite sure. Um, Even if I use dynamic programming, then I can't basically store the actual number in the state of the recursion to compare whether it is larger than some other number or not. So to solve this, brute force is not an option for this. So let's see. So since this is a subsequence choice, it is not that straightforward. What I can do is start with any digit and try to construct the best possible answer for that particular starting digit. So let's say we have 9, then we can have either a number for any digit. Let's say for 5 there is a bigger number to the right of it, then that should be our first priority, because we are constructing a number which is exactly 12 digits long, and that means we need to put I mean, if we have a choice to put a smaller number or a larger number, irrespective of what later numbers we are going to insert, it is always better to insert a larger number initially. Okay. What I can do is, let's say I start at 4. So if I start at 4, I start constructing a number at 4 for this third sample test case. I think this entire thing is selected, right? So 6, 11, 12, right? If I have to select 4 here, then I may not be able to create a 12-digit number because there are only 11 digits, including this and this part. That's why 3 was a better. I hope I'm live right now. Okay, fine. Let me create the input. Fine, as long as we have lines in the input. Let's convert this into, that is also not required, in fact. Line dot size. So for this is at most 100. I mean exactly 100 for the larger test case and 10 for the smaller one. And now I was doing this. So let's say we are creating the best possible answer for this case. Let's say this is 0. And there is final answer that I need to use as answer, which is the sum of values for all of the intermediate answers for each of the inputs. So here I will have to add the best answer for each line after it is computed. So let's do the computation here. I have the length, so I will start choosing the numbers from left to right. And the digit is, what about leading zeros? I don't think we have leading zeros. I think we have only 1 to 9. I read it somewhere. I think it was in somewhere. Yeah, it is only from 1 to 9, so we don't need to care about leading zeros for now. Cool. Let's go ahead. This is sin of I minus 0 because these are Unicode characters in the string and I'm converting them into integers. After this is selected, we are constructing a 12 digit long number. So the number constructed is, let's say, number starts with digit, and after this we will basically have some starting index. So let's say idx is I plus 1, and we need to create a 12 digit number, so we will have to digits remaining is 11, and as long as the digits meaning is greater than 0, we will start choosing the numbers from this particular index to the right of it. So once since we have chosen a single digit at index I, the next range starts from I plus 1, and after this, so I need to find out by moving to the right what is the highest number after choosing which I can still create a 12 digit long number. So I will have to start a loop from IDX all the way up to the last index, and see we have chosen index as -1. It could be possible that we don't find this, that's why I've kept it as -1. This is the new digit that we are appending to the number we are constructing. The new digit is line of j -0, and I need to find out how many numbers are there to the right of this particular index that I can find out by doing. So let's say 0, 1, 2, 3, 4, 5 is the indexing, and I am at currently at 3. Then if I do length minus index -1, then I will get the actual. Okay. Right digits is length minus the index -1, right? So the length of this particular example is 6, index is 3, and -1 becomes 2. So there are two numbers to the right of 3. So I can take this particular digit if right digits okay. So I also need to keep a track of how many digits I've already taken. Instead of doing this, what I was thinking of doing is, let's create a string number and append this particular value to it. A digit is greater than equals to, so we have constructed a number which has a length of number dot size, and we are going to take this particular digit, so this should be +1 bit. So let's do it simply. Digits taken is length of the number +1, and digits required would be 12 minus digits taken. So if the right digits is greater than equals to digits required, then we are good, and we can say that we can take this particular index. So before taking any particular index, there could be a multiple possible choices for them. So either chosen index is -1, then this is the first choice that we have. Then we can simply take this particular index. Index is j, else I need to check whether which of those two is larger. So how do I do this? Shows is -1, then we should break, else we should append this particular character in our final number that we are constructing. And this number that we are constructing is for every starting point, right? So I think this is a lot of nesting. I hope I'm not confusing this too much. Line of Poisson index. And this condition should be line of I don't think this should work. It could be possible that there are two numbers which are the highest ones, and there are enough numbers to the right of it. So in that case, we should choose the earlier one. I think that, how do I handle that? Line of j is greater than line of chosen index. Only in that case, I should update this particular value. Let's merge these two conditions. Once this is done, then let me 2 digits remaining. I think this should be fine. And else I had to do. I also needed to update this particular index. The next iteration should start from there. And IDX is an index +1. One more thing that is remaining is updating. Okay, this is updated, perfect. And what else? Chosen index I've updated. Perfect. So let me get the best value from this. Since we are constructing a number which is of exactly length 12, and so we don't need to do an integer conversion and then check them numerically. The lexicographical comparison should yield the same result as numerical comparison when the sequence of digits has the same length. So this is the number that we have constructed, and I need to maintain best somewhere. So let's make this best and update the best here. This should require a string to long compare, and also print this. Print best. And let's also update the bus here. I hope there should be some mistakes here, but let's try to run this. The input. Okay, for the first case, nothing is working. I also need to do one more thing here. If length of number is 12, in that case only I need to update it, because for all the cases where we start from a digit which doesn't have enough digits to the right of it, we are constructing a smaller number, and the lexicographical comparison always will mark 9 as a larger number as compared to other one. So let's make it a constant. Let's make it len. Wow, so if I got the correct answer in the first attempt for the sample disk is, let me also verify this. 7 looks good. 434, 234, 78 looks good. I think I'll run it for the larger input and cross fingers. Correct. So yeah, I mean, not that difficult in terms of idea, but the implementation would have been tricky. So I tried to simplify these things, because if I just try to clutter this in the same condition, it becomes difficult to debug these later. Okay, let's commit this. I need sample input. Did I not commit the part 1? Why do I have I copied this to main too, but I don't think I need that right now. I can discard this. I need and the sample input. I have the main input committed. Okay, so it would be let me do this here. Remove the binary. This okay. Solved day 3 part 2 in C++. Let me create a Git repository for this as well. Let's say if lazy Git allows me to directly. Advent of Code 2025. Solutions to Advent of 2025 in plus multiple programming languages. I might also use some other language later. Okay. deny it, readme. Let me use main branch. Okay, so all the code until now should be visible here. If you guys want to check it out, I will add the link to this in the description. Okay, perfect. Let's move on to day 4. I'll probably take a 2 minutes break right now. Okay, I'm back. Let's go to day 4, part 1. You ride the escalator down to the printing department. They are clearly getting ready for Christmas. They have lots of large rolls of paper everywhere, and there is even a massive printer in the corner to handle the really big print jobs. Decorating will be easy. Make your own decorations. You really need is a way to get further from the North Pole while the elevators are offline. Actually, maybe we can help with that. One of the elves replies. You ask for help. We are pretty sure there is a cafeteria on the other side of the black wall. If you would break through the wall, would be able to keep moving. And it's too bad for all for Apocalypse. Is he moving those big rolls of paper around? All this seems irrelevant, but let's start here. The rolls of paper marked by at the rate are arranged on a large grid. The elves even have a helpful diagram, your puzzle input indicating where everything is located. Okay, the forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. If we can figure out which rolls of paper the forklifts can access, they'll spend less time looking and more time breaking down the wall to the cafeteria. In this example, there are 13 rolls of paper that can be accessed by a forklift marked with X. Oh, they haven't given the explanation for the 13. The forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. Can figure out which rolls of paper the forklift can access and less time looking and more time breaking down the wall to the cafeteria. Input rolls of paper are marked by at the rate. Paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. And I hope the forklifts can only operate on the positions where you don't have a roll of paper. I don't think so that is the case because there is a roll of paper at this position, but they have marked this as X. So we need to consider all the positions in the grid. Sorry. Yeah, I mean, very simple. Just check 8 adjacent positions, count of at the red symbols, and check if it is less than what is the threshold? 4, less than 4. Start with day 4 implementation. I'll use C++ again for this. Okay. Let's store the grid as a vector of strings matrix. We get line from the input. We append the line. I hope the column size stays same, or maybe this is larger. That's fine. Yeah, I can deduce the number of rows and columns later. So dot push backline, number of rows will be mat dot size and columns would be mat 0 dot size. To go over all the cells. And let me also write down a direction vector which will help me to go over all the adjacent directions. Let's use pair of int for this. Dx, we have 0 1. I think I'm only writing dx's, right? So this should not be required. Yeah, 0 0 0 1 minus 1 minus 1. Not sure, maybe I'll correct this. Minus 1. What else? 0. Let me keep this blank for a while. And this should be 0. So need 1 1 minus 1 minus 1. I need minus 1. How many are this? 1 2 3 4, and this is extra. Hmm. 0 1 0 minus 1. It should be, let's remove these. 0 1 0 minus 1 1 0 minus 1 0. Minus 1 minus 1 is fine, and one more is 1 minus 1. I hope this is 8. Yeah, let's go over all of them. It is less than 8. Plus I get the coordinate of neighboring cell as I plus dx of id and j plus dy of id. This should be neighbor of j and j. And the issue here, can I not initialize it like this? Okay. Yeah, I mean, check if this is inside. If it is inside, I need to get the count of at the rate. So count plus equals to mat of ni and j is at the rate. And this should be outside. And if count is less than max allowed is 4, answer plus equals 1. Answer is 0 and max allowed 4. And let's print the final answer. Part 1 answer is okay. I need to move to the day 4 directory. Compile. I don't have the input yet, so let's check this. Okay, thank you compiler for this particular error. In one, okay, GCC G++. Okay, 29. Definitely not correct. Lives can only access a For example, there are 13 roles of paper that can be accessed by left. Let me mark the ones that I'm assuming as valid. See, Boolean. Oh, let's make it a character. It won't allow me to do that, so use a string result, which is a vector of string with n rows and string of length m. It's not allowing me to construct this. Is this fine? I don't think so. C++ create string with length. It's fine. I'll probably result of I is again it's the same situation actually. I'll probably update all the characters in this. Result of I should have probably used Python for this. Pushback. I mean, I should have used the input matrix itself. There wasn't any need to do anything special. And what else? Result of this should be updated to X. And let's print this. I'm just debugging the incorrect solution. So this is marked as X in my solution, even this. Let me go over the question once again. Maybe I have missed some validation. The rolls of paper are arranged on a large grid. The else you can have a helpful diagram where everything is located. The forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent position. Fewer than 4. What if the definition means that not just adjacent but in the direction of adjacent? Maybe like I need to consider the entire diagonal or the entire row. The forklifts can only access a roll of paper if there are fewer than 4 of paper in the 8 adjacent position. No, I mean this statement does make sense compared to what I'm doing. The forklifts can only access a roll of paper. Let me check my implementation. I mean these doesn't make sense why this is marked. And this should have also been marked in that case for my solution or not. So let me also print the input that I received. See here. Input looks correct. There is no issue with the input. This is also correct. I'll go through the question once again. Get further into the notebook basis. The elevators are offline actually. Maybe we can help with that. Bill supplies for help with issue. There is a and still that doesn't make sense why in this example there are 13 rolls of paper that can be accessed by a forklift marked with X. But why not this position then? Or they are only considering the positions where a roll of paper is already present. For example, I mean from the sample input and sample output, the that case is evident, so I'll probably go with that. So this condition and mat of ij is at the rate. Okay, now I'm getting 20. What else is missing? What about this position? Okay, that is fine. This position, my solution has used this position. 1, 2, 3, 4. Why did my solution use this particular? Max allowed is 4. Count n m I plus dx plus dy. This position should not have been selected. Mhm. Should I debug this? What is the length of this? 3, 6, 10. This is the last row, row number 8, row number 9, and column again 9, 8. Yeah, I mean, from the result vector, it is evident. Also, print the count here, because this shouldn't have been selected. 1, 2, 3, 4. It's clearly 4 here. For 9, 6, the count is only 2. Why? I have 8 directions here. This should have been taken care. Okay, let's find out the counts for if I is 9 and j is 6, right? So this particular position 8, 9, right? Just to print the adjacent values selected here. Why is it 1050? There is some small bug somewhere. I'm not able to catch it. Mhm. This doesn't make sense. 1050, where did it come from? Zero. I think this is happening for multiple inputs. So either this is overflow, some is fine. Where is this coming from? This is happening for I equals to 9. I mean, for all the rows, it's happening. One, two, three, four, 7, 8. This is also correct. Let's check the input file. Mm. Let's check this line by line. Taken the input. Let's see what is the rows and columns that we are extracting from this. Maybe there is some extra empty line added at the end. And now this is going even beyond. That's correct. Hmm. This should have been a comma. Wow. Silly mistake. The sad part about it is like C++ is not even complaining. There is nothing to complain, but at least you have a static expression. At least there should be a warning in that please evaluate this to a fixed constant. Yeah, nice. Let's solve the main one now. I'll remove the comments. Mhm. Let's also remove this. Larger input 1578. Okay, let's move to part 2. I'll commit this first. Edit this, and discard this. Hit this, and yep, solved. T4 part 2 in C++. Push. Uh, cpp main2.cpp. Okay. Now the else just need help accessing as much of the paper as they can. Once a roll of paper can be accessed by a forklift, it can be removed. Once a roll of paper is removed, the forklifts might be able to access more rolls of paper, which they might also be able to remove. How many total rolls of paper could the else remove if they keep repeating this process? Starting with the same example as above, here is one way you could remove as many rolls of paper as possible using highlighted at the red to indicate that a roll of paper is about to be removed, and using X to indicate that a roll of paper was just removed. Highlighted at the red to indicate that a roll of paper is about to be removed. Okay, understood. Five rolls of paper. one roll of paper. Hmm. But why are they doing this in a grouped fashion? And can't we just go one by one? Starting with once a roll of paper can be accessed by a forklift, it can be removed. Once a roll of paper is removed, the forklift might be able to access more rolls of paper, which they might also be able to be removed. They might also be able to remove. How many total rolls of paper could the elves remove if they keep repeating this process? Taking the same example. I mean, does the order matter? I don't think so, because if you remove a roll of paper from any cell, it would be better for the next forklift, because it will probably reduce the number of adjacent rolls of paper. So I think order doesn't matter. We just need to keep doing this as long as there are enough um, cells. Um, okay, I will probably go with that approach only. I'll probably go one by one and check if it can be removed, then remove it, and then again start a new iteration. Start with the original diagram. Hopefully that should not be too time consuming. Let's see. What I'll do initially is I'll probably, I don't know this. I'll get the coordinates of all the rolls of paper. So let's use a set of, I'll probably use a vector only. Cells to check. So I go, let's use this. And if mat of ij is at the rate cells dot pushback make pair ij, and let's see. Again, I want to do this as an infinite loop. While true, let's say there is one boolean which mentions whether we found something or not. So this should go over auto ij in the cells that we already have. And let's do one thing. Let's remove them in batch instead of one by one. And can even do this. New cells. And let me also write a helper function. Can or let's say eligible ij, and this goes over all the neighbors and returns this. Okay, We need a count and simply return this expression. This returns a boolean. And what else? This condition is not required because we are already pushing the coordinates with at the rate in the first place, so that should be fine. If eligible ij answer plus else, and we also need to do a found equals to true. What else? If there is if it is not eligible, it could be eligible in the next attempt, so I will probably push the coordinates of those for the next iteration and update cells with new cells. We don't need this now. Let's compile main2 on sample input. Okay, I think I've missed the termination condition. If not found, break. Looks like the answer is not correct. One reason could be that I'm not updating this particular matrix, which I need to do. And while doing that, the ordering could matter, but I think the cells which are missed in the first iteration could be taken care in the next iteration. Yes, I think that doing this should be fine. Okay, 43 looks good. Let's try the larger input 10132. That's right. So yep, day 4 is complete. I think this probably looks a better code as compared to other days. Commit this. Solved day 4 part 2 and C++. Sorry, pull. I need to push this. Okay. Day 4 is done. Let's go to day 5. Okay, I'll be back in 2 minutes. Okay, let's go over day 5 quickly. As the forklifts break through the wall, the elves are delighted to discover that there was a cafeteria on the other side after all. You can hear motion coming from the kitchen, XYZ, XYZ. The elves in the kitchen explain the situation because of their complicated new inventory management system. They can't figure out which of their ingredients are fresh and which are spoiled. When you ask how it works, they give you a copy of their database. Database operates on ingredient IDs. It consists of a list of fresh ingredient ID ranges, a blank line, and a list of available ingredient IDs. Okay. The fresh ID ranges are inclusive to 5. Ranges can also overlap. An ingredient ID is fresh if it is in any range. Okay. The else are trying to determine which of the available ingredient IDs are fresh. Can't be that simple. And maybe they are preparing something for part 2. 3 available ingredients process the database file from the management system. How many of the available ingredient IDs are fresh? Let's go ahead with the part 1. I don't think I can possibly predict what the part 2 would be, and trying to find out any optimized solution. But yeah, let's try. Think we do split on 2 new lines to get the first half, the second half. Let's try that. Parts input dot read dot split on this and end parts. Py input dot. How do we do this? Okay. Oh, I was just checking how to get the parts individually for this particular snippet. Let's print this. Okay. Where is the input? There. Okay. Looks like this is passed correctly. I will have to recursively get them. So ranges should be parts of 0 dot split on new line, and coordinates should be parts of dot split on new line. So I will probably go through all the points and chords and found I will keep a boolean variable for finding out whether it is present in that particular range or not, and go over all the range. And R should be LR split on hyphen, and what else? Map them to integer. Hopefully this does the tuple magic of converting the stream into vector value. If in range LR plus 1, I can simply do this and break. Part 1 answer is 0. Wow. Let's check. What happened? I think I need to map this to integer. What is the value for that? Let's print this first. Is this value? Okay, let's get this as a list. Maybe there is a trailing thing where it's one dot. Can I trim this or? Mhm. So this is fine, just there is one empty string in this. So we find out Python split string exclude remove empty. Let's do it in a simple manner only. If len of c is greater than 0 and int c is in this range, answer is 3. Let's remove these comments and get the actual input. 773. Correct. Let me this binary file. I'll probably commit all of these. Commit solved D5 part 1 in Python. Let's go to part 2. They'll start bringing their spoiled inventory to the trash chute at the back of the kitchen so that they can stop bugging you when they get new inventory. I also like to know all of the IDs that the fresh ingredient ID ranges considered to be fresh. And ID is still considered if it is in any range. Now the second section of the database is irrelevant. Here are the fresh ingredient ID ranges from the above examples. 3 to 5, 20. The ingredient ID that ranges considered to be fresh are this. Okay. In this example, the fresh ingredient IDs ranges consider a total of 14. Okay. So I just need to find out the intersection and count of sorry, not intersection, the union of all the ranges and the sum of, not sum, but count of the elements in the union of these ranges. Yeah, yep. Let's do a union. To do the union, we usually do C++ would be better for me in this. So string time vector of int ranges. We only need to take the ranges. If C++ string contains character find. Okay, so if find dot find, there is a hyphen, it's not equals to unpause. That means we found it, and we can ignore the rest of the input lines. But again, this splitting is slightly bad. Can I find the index of this dot big? Does it say? Find index of character. Okay, it directly returns the index. Perfect. I thought it returns the iterator. Yes. First try to check if it is giving me values. plus plus. We have main and yep. Okay, perfect. So this is fine. Now I need to get the left value as string to integer of line dot substring from index 0 of length idx plus 1, and the r value would be idx plus 1, the substring starting from idx plus 1. Let's also print this. Okay. Add these ranges. The ranges list and sort this ranges. So the way we do this is basically we have a ranges. First element in the ranges, the left hand point of the first element in the ranges will obviously be the leftmost id of any range since we have sorted it. So we need to start from the second one and the value is too large to be stored somewhere. Yeah, I don't think these could be stored. So we start from the first, then we check for how long can we expand this range until there is no intersection or union uh, between the set of ranges that we are going through. So we start at index 0. And let me do the incrementation inside. So this is our range. So first and ranges of I dot second. Now we will start the loop from the next one. So let's say plus 1 while j is less than n. Yeah, I mean, so if this how do I do this? Check whether so this lr is substrate dot first second. So if this l is less than equals to the previous r, so for now let's say this r extends to the right max. If this extends, then r also needs to, I mean, if they intersect, then r needs to extend. R is max of, come on, it's r. If they don't intersect, Um, then the answer would have the contribution of this LR. If I have to visualize this, can draw? Dark mode. Okay. Uh, let's say I'm at this range. L and R for this initial range should remain the same. For this also it should remain the same, but for this it should be R should point here and L should obviously point here only. And this loop should break when we don't find any common range after this, right? So this computation is done. We need to the answer by R minus L. These many unique IDs are present in these ranges, and we'll start the next iteration for this range. Here what I should do is like this. Okay, and since these are not intersecting, I should take and the smaller ones that I'm iterating over are these LNRs. So initially this R started as a endpoint of this segment, and eventually this same variable is getting updated over the small r's, right? Okay. Else, once I've added this in the answer, I need to get this particular iteration, but or else what I can do is, let's not add to the answer here. Let's add to the answer here, so that even if this loop doesn't find anything, I will have to separately consider a case where we found something here, or there is a single range which should be considered in the answer. This is done, and we need to J I is J. Let's try this. Okay, 14 seems right. I hope this is correct. I probably have to go through these larger input only. S2. Oh, I failed. So where did this fail? Let me see. Okay, STOI. I don't. We need to use STOLL since these are larger than 32-bit integers, I suppose. And I already have a macro to define int as int6040, so should take care of it. Let's try this. Cool. So yeah, this should be it. I hope this diagram is clear for what I'm doing. And the time complexity is still, I mean, this sounds like a nested loop, but it goes over all the indices at most once. So only sorting is the bottleneck, order and login. So there should be a optimized approach. I don't think even the input would have allowed a naive approach here, but yeah, looks good. Overall, I think the problems were quite easy. First 5. I'll probably end the stream now, and I'll probably get back to the rest of the days later. So I have both of the solutions, right? Okay, cool. Let's discard this binary, stage this, solved A5 part 2 in C++. Push. All the code is available on the GitHub repository. I'll add the link in the comments. Cool. Sounds good. Bye bye.